First thing, I'd like to thank Natasha Ritzma and Georgia Schwender for putting this together and inviting me here. It's always an honor. My name's Don. I'm a physicist at Fermilab. I do particle physics research. I've been doing it, well, since I was the age of the students here. I spent the last 35 or 40 years trying to uncover the laws of nature. I mean, that's what particle physicists do. And so what I want to talk about here is to give you a sense of what the most modern physics understanding of the building blocks of reality. So what that really means is we know, we have an intuition of the world around us. We know that we can walk through air, we can't fall through the floor, and all of that. So we have a real clear gut feel for what the world is made of. However, over the course of the last 100 years or so, physicists have come to realize that much of this is an illusion, or more to the point, the deepest and most fundamental building blocks of the universe around us are very different than our intuition. And so that's what I'm going to talk about today. I'm going to basically tell you, I'm going to really surprise you, I think. So, but before we do that, I want to warn you. And the thing I want to warn you at is that the following talk could easily be misinterpreted as supporting an awful lot of mystical mumbo jumbo. And so I don't want you to walk out thinking that I am supporting that. On the other hand, many of the things I will say really sound a lot like some of the things you might hear. So, first thing is, it doesn't. And the second is, you've been warned. So, now, if you want to take what I say as confirming some belief, that's your business, but you're doing it on your own. All right, so we are in an art facility, so I would like to remind you, perhaps something of which is very clear, that the universe the world, it is fundamentally beautiful. I mean, there are things, and I'll show a series of pictures here, that are just breathtaking. And a lot of reality is just that. There are things like this beautiful rose, something very, very different scale, but the planet Saturn. And, what's more breathtaking than a beautiful sunrise or sunset? Each of these phenomena, whether it be the rose, the planet, or the light breaking through the clouds, occurs from a different, they're very different. They're not the same, and yet they all invoke a beauty. And, same thing with living matter, this beautiful swan. But what I want to talk about here is a deeper beauty, a sort of intellectual beauty, about how all of those things, everything I just showed you, are in fact very fundamentally similar at the very deepest levels in ways that perhaps are surprising. And so this here is what's called the Flammarion wood engraving. Some people call it a woodcut, and I'm told that by experts that it in fact is not a woodcut. And it's called the Flammarion engraving, not because Camille Flammarion made it, but because it appeared in the front piece of his 1880 book, L'Atmosphère Météorologique Populaire, which is my bad French accent for the atmosphere popular meteorology. The author of this engraving, or the artist, is unknown. It's lost to history. However, it's very evocative of precisely what this talk is about, where you have the world, the visible cosmos that we see around us, and you have this person peering through the veil, looking at the gears and the workings that make it all happen. So, I would like to start by reminding you that this is not a recent phenomena. So, I really like this painting, and probably many of you know it. It's the Scuola di Atene by Raffaello Sanzio da Urbino, or for me, it's the School of Athens by the artist Raphael. It exists in the Apostolic Palace in the Vatican, and it was painted between 1509 and 1511. But the reason I put this up here, partially because it's really pretty and I like it, but partially it is a reminder of the heritage of Western culture, which has long been interested in the questions that I'm going to talk about here. And so the various people are different philosophers. It's a representation, but I want to draw your attention to one of them, this guy here, who is Aristotle. So Aristotle was one of the early people thinking about the nature of reality. He's portrayed next to his mentor, Plato. And Aristotle came up with perhaps, or wrote down, the first sort of, not quite quantitative, but conceptual idea about the material of which the universe is created. And so he said, when we look at you, me, animals, rocks, and so forth, we can dig down, and what we find is that they are made of 4 distinct elements. And they are water, earth, air, and fire. And there was another element which is not mentioned as much, the 5th element, the void, in which all of these things combine. And the idea was that something that actual fire, like what we think of as fire, was a mix of the elemental fire and air, because when you burn something, it gets hot, but it floats up. So it was a mix of elemental fire and elemental air, and that's what real fire is. Now, we don't believe this anymore, but I wanted to remind you that this is not something that physicists have just come up with in the last 100 years or so. What it is, it's an age-old question asked by people for literally thousands of years. And our understanding has evolved, but the drive to understand is the same. So nowadays, this is what we would call the elements of nature. So the material that we are made of is made up of different combinations of a little over 100 chemical elements. Now, don't worry, there's not going to be a chemistry test or anything, but I want to remind you that we've gone from the 4 elements that are sort of metaphysical to these are actual things that we've measured, and we know very well how they tie together. But I don't want to get into the chemistry so much. I want to remind you, you probably saw this in maybe 3rd grade, the different levels of matter. So you have solid, and you have liquid, and you have gas. But the one I want to draw your attention to is the solid one over here, because it's a really nice sort of conceptual idea of what happens with matter. So each one of those little blue circles is supposed to be an atom or a molecule of some sort. And it sort of shows you that the reason you can't put your hand through something is because the atoms are all too close to one another, and there's just no space to go between them. And you kind of get a little bit of a sense of that, like if you were in one of these ball pits, like when you were a kid, you jump in and all the balls moved around. But that's more like liquid because the balls can move around. But in the case where they're all packed together, that is a common understanding by most people of what the nature of matter is like. But I want to give you a different sense of it. And so I'm going to start with something that you've probably taken in a class in high school, perhaps, and the idea that something like water is actually made of molecules. So you've heard water is H2O, and so that's all that's a picture of. Now, the thing to draw your attention, those letters are a little small, perhaps. You have a dewdrop, might be a millimeter in size, but a water molecule is much, much smaller. It's about 10 to the minus 7th meters, so it's about a little bit more than a millionth of a meter, so it's really tiny. Or, if you know how big a millimeter is, and these molecules, if you have a millimeter, you can put about, say, of order 3,000 of them side by side within a millimeter. So they're very, very small. And so that's the first, perhaps interesting thing, is that the world, the building blocks of reality are much smaller than anything we can see. And so that's why it took us so long to understand this. But now I want to really kind of mess with your head, because while water is H2O, H is hydrogen. It's the simplest atom of the simplest element. It consists of a single proton at the center with an electron swirling around the outside of it. And the size of an atom is about 1/10 of a micrometer, so 10 to the minus 7 meters. It's very small. And this probably is the mental image that you have in your head of what an atom looks like. This is something that's very common, where the sizes here are terribly disproportionate. They're wrong. But the idea is that you have a nucleus at the center, and you have electrons swirling around the outside. And while that is something that we often see, it is a little bit misleading. And so I want to just give you some sense of scales. So what are the sizes of these things? Well, an atom is about 10 to the minus 10 meters, so very small. But the nucleus of the atom is 10 to the minus 14 meters. So the nucleus, or the atom I should say, if you look on its radius, it's 10,000 times bigger than the nucleus. But that's the radius. If you look at the volume, you have to do a little bit of math. Don't worry, that's the only math, and we're not really going to do it. But if you want to figure out the volume of something, you need to know its radius in cubit. And if you do that, what you find is that the volume of an atom is about 10 to the 12th times bigger than the nucleus of an atom. And that is 1,000,000,000,000 to 1. So an atom is very, very big compared to the nucleus. Of course, we've been studying the nucleus of atoms since like 1930, so almost 100 years. I want to give you a sense of scale. So this picture is not quite perfect, you'll bear with me, but suppose you had a single proton and you blew it up to the size of a millimeter. Now these BBs are actually 3 millimeters, and that's just because I couldn't find a picture of a handful of millimeter-sized BBs, but it kind of gets the idea. So let's just suppose one of those BBs is a proton. If that was true, what would the size of an atom be? Well, the size of an atom, well, we have this lovely picture of downtown Chicago, and what an atom would be is it would fill up Soldier Field. So to give you a real, I like this because it's very intuitive. If you were to talk about a hydrogen atom, you would have a BB on the 50-yard line of Soldier Field, and the rest of the atom would be an electron, which is like the size of a dust particle, flying around in a big sphere the size of Soldier Field. And so that leaves you to a very, very simple conclusion. And the simple conclusion is you're mostly empty space. So that is a very bizarre concept. Why is it that you can't put your hand through something? I mean, that picture from 3rd grade said that all of the atoms are packed close together. And that is, well, the atoms are packed close together, but if the atoms are empty, why is it that you can't put your hand through, say, this? And the reason is a combination of things. Partly it's because there are electric fields holding the electron inside the proton, or not, sorry, inside the atom, and it's basically those fields fighting with one another, and the fields can't pass through each other, even though they are not substantial. And then there's another more complicated thing, because I know there's a chemistry professor here, having to do with the nature of how electrons talk to each other. Basically, electrons are like cats. They sort of don't like to be together in the same place at the same time, and they push each other apart. But that's a separate thing. The real takeaway message is that atoms and you and me and the floor, the earth, everything are basically empty space.